All right, guys, just to be sure, you are all aware, this is the way my website looks. It's at iatkin.com, and you have a lot of material posted on this website. Good. So the syllabus is posted right here, and the other information for this class, the code is for Hunter College, but the material is the same for us all. So it's Math 150 Calculus 1. If you are having some prerequisite issues and you don't remember everything from what you're supposed to know before you take this class, you see this Advanced Calculus textbook here, the top link. You click on it and you see 3 books. The middle book is the supposed textbook that we're using. And when you have here at Howard Anton Calculus, if you click on this link, you can find Appendix A through E. And in these appendices, you can find a good review for the material with practice questions and solved exercises. In general, as we introduce material, it's a good idea to solve odd questions from the corresponding chapters, okay? I titled my lecture notes based on those chapters. So for example, so here, calculus lecture notes, it's a good idea to go over them. So one is limit. And well, where we are somewhere here, I think. All right, so we covered this information. So this corresponds to limit laws in your textbook. That's roughly where we are at. And now let's begin talking about polynomials. We are actually going to introduce some functions and try to explain what are the simplest functions and why they are important and what maybe you can be able to do with them. Okay, so in the other class, somebody already asked me, what's the idea of calculus? Okay, what's the purpose of calculus? And you see this idea at every moment of your life. When you listen to music, when you're watching videos, when you play Lego, you see calculus at play. So the idea is that when you try to describe anything, the lecture recording, guys, I guess I should email it again to you, or it's on YouTube, okay? You type my first and last name in YouTube, you find my channel. They're posted in my channel, and you can see the latest videos. Just search for the latest videos, you will know them. This class is titled Morning MS21 Calculus. There is also ES21, that's the evening section. So both sections are recorded, and you can watch whichever lecture you prefer. Good? All of you know where to find my video lectures, yes? Just what you do is here, guys. You go to YouTube. You type my name. And here's my channel. You go in, and you can see S21, probability E, S21, M, S21, those are the lectures for this particular section. ES21 are the lectures for the other section. You can decide which you prefer. Okay, it's up to you. Clear? All right, back to this lecture. Again, guys, when we try to analyze functions, we can ask what is the simplest type of function, the simplest species of function that we ever encounter. So for that, ask yourself, what are the simplest mathematical operations? In elementary school, you learn addition and multiplication. Division, addition, division, multiplication, you might say, right? Subtraction. Addition and subtraction can be thought as really the same operation. So if I subtract from 5, I subtract 2, 5 minus 2, it's like 5 plus minus 2. You understand? It's like adding to 5 negative number. So when you first encounter operations of addition, subtraction, multiplication, then you can think of 5 minus 2, as I mentioned, as 5 plus minus 2. So you can think of the first operation, whether it's addition or subtraction, as just addition. Okay? And the simplest functions, therefore, are the ones only using the operation of addition and multiplication. Do you agree with me that those are the operations you begin school with? You say, you begin with addition and the next operation is multiplication. Good? So here we have f of x equal to 5 plus 2x minus 7x plus 1 plus 2x minus 3 squared. Do you agree that in this operation, what am I doing? I am taking a number. What is x? X is just a number. And I multiply this number by 2 and add 5 to it. I take 1 plus the number and multiply by minus 7. I take this number minus 3, square it, and multiply by 2. Squaring is multiplying this expression twice by itself. So you agree that here I only use addition and multiplication. Correct, guys? No problem, right? I mean, and you can say minus, but minus is addition. We're going to regard it as addition. It's convenient for us. Good? So function that uses only addition and multiplication is a polynomial. And if you look at it carefully, guys, I can expand it. I can just do algebra, and I can group the operations by the number of times the input has been used. You agree? So here, it's grouped, however, haphazardly. We just use addition and multiplication. But I can decide to present this information by regrouping. Just changing the operations, expanding, squaring this thing. You see what I do here? I expand the square, I simplify everything. And I can group the expressions based on the number of times the variable x was used. So I can reduce this expression to 16 here. The variable x has been used no times. Minus 17x, so here the variable x was used once, so you only multiplied once by the input, plus 2x squared. Here you multiplied twice by the input. Do you understand, guys, what can be done? That if I have operations involving an input and the operations are only addition and multiplication, I can neatly group those operations by the number of repetitions, repeated uses of the input. Yes? And here is what we define a polynomial to be like. Okay? A polynomial is a function p of x that can be written as p of x equal to a0 plus a1x plus a2x squared, blah, 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 plus an x to the n, where n is a non-negative integer. It's 0, 1, 2, 3, etc. Okay, and those are just constant. Those are coefficients. What that means, those are real numbers. Okay, so in particular, here is a real number without multiplication by x, another real number multiplied by x plus another real number multiplied by x squared. Okay, and that terminates after a while. You understand what is this? Not only the definition of polynomial, by why we define it, guys. Polynomial is supposed to be the simplest function because it uses the least amount of vocabulary, the least amount of mathematical operations. Okay, this symbol, by the way, means belongs to. So those stand for numbers that are members. They're real numbers. They are members of a particular club. Okay, and here are some notations. So n is natural numbers. So natural numbers is 1, 2, 3, 4 positive integers. Z is integers. So that means 0, plus minus 1, plus minus 2, plus minus 3, etc. Now the letter Z is used because Z in German means Zahl, and Zahl in German means number. Okay? So basically in complexity, you can think of natural numbers as where you start from. Those are the simplest numbers. And then you have integers, which are not that much more complicated. Then the next level is quotients, Q, rational numbers. The reason we use Q is because it's quotient. So we take integer divided by another integer. Good? Integer, by the way, integrity means your whole. So integer means whole number. Okay? And what is R? R is the real number. So I mean, nobody was that obsessed about it last office hour. Maybe you were tired. I can give you a sort of idea of what real numbers are if you want to, how they were developed, at least a geometric idea of what they are and what multiplication and addition of real numbers means geometrically. So R is the real numbers. Those are the numbers that supposedly we know how to use, even though to actually understand what they are, it took a long time. It was in the middle through late 19th century when a very good understanding, very logical understanding of what this means has been developed. Okay, so most likely every number you have ever seen is a real number. Maybe some of you have seen a complex number, but you probably don't understand what complex numbers are at all. So we have subsets. So we have this membership. So every positive integer, every natural number is an integer. Every integer is a quotient because you can take the integer divide by 1. And every quotient is a real number. Okay, a real number is the biggest category that you know. Now let's see if you understand what is a polynomial and if you can identify them. Okay, not only the definition, but if you can understand what is the idea. Okay, so tell me by definition why it's a polynomial, and also maybe tell me what's the idea of a polynomial. That's even more important. Okay, so which of those are polynomials, guys? So let's begin this work. So tell me please if a f of x equal to 5 is a polynomial.
No.
Okay, so so one person says no. I think I heard Tzvi saying no. Am I right, or maybe I'm wrong?
That was me, Robert.
Okay, Robert. Sorry, Robert.
Oh, I think it is a polynomial, Professor.
Okay, so of course, I mean, to ask whether what it is a polynomial or not, you first have to ask yourself, what are we talking about? What is a polynomial, as Francis is asking again? What is a polynomial in, you know, common day language? What is it what we're saying? Polynomial is an operation, is a function that uses only addition and multiplication to calculate. You understand? What is an operation? You feed in an input, then the input is being processed through various algebraic routes, and then boom, you get a number out. Okay, so you all understand, guys. Some of you don't understand what is x. What is x? It's just put something in. It means put a number in, and what will happen to the number? It will be processed and the output will be 5. Is it a polynomial or is it not a polynomial?
It is a polynomial.
Okay, so somebody is saying it is. Let's see, who said just a moment ago it is a polynomial? Let me, Christiana. Yes, Christiana, would you tell me why is it polynomial?
Yeah, so based on the polynomial formula, that is like a plus a1x plus a2x squared and so on.
Right, this one, you see? Good.
Yeah, so we can do like 5 plus 0x plus 0x squared plus
Beautiful, Christiana. You understand the formal definition. If you were a computer, that's exactly right. You conclude what we have is a polynomial because we have the first coefficient is 5, a0 is 5. Everything else, you see, is assigned the number 0. So by pure definition, it is a polynomial. Let me just show you on the board what happens. Okay, and guys, if at some point you're confused, again, tell me what happens here. So we have f of x is equal to 5, yes? And then I can simply write plus 0 multiplied by x plus 0 multiplied by x squared onwards, right? So you can see that I can make it an operation that only involves addition and multiplication, but most of the operations are using trivial multiplications, right? So it has the right representation. Good? Do you all see that, guys? That I can get the number 5, but only employing addition and multiplication. I don't need more operations.
Professor?
Yes.
Isn't like for it to be a polynomial, it needs like more than 3 terms in it?
No. I mean, forget anything that anybody, maybe you've heard quadratic polynomial, who knows what you heard for many times. think about what matters here, right? What matters is we're trying to classify the simplest functions. You see, we're trying to create a building block, okay? And the building block here is what the simplest operations that we understand involve addition and multiplication. Yes? So any operation that only needs to use addition and multiplication is going to be called a polynomial. Okay, and you should remember, and Christiana, you too should remember it. So why did we come up with the definition? Is that any operation involving addition and multiplication, if you want to, we can do one example, right? So let's do one simple example so you can see, right? So suppose that we have g of x to equal to 3 minus 7 x plus 2 plus x minus 1 squared, right? You can see it's not in the form constant plus a constant times x plus a constant times x squared. But look what we can do here. Do you see that we can take this and we can write it as 3 minus 7x minus 14, yes? And then here I can expand x minus 1 into x squared minus 2x plus 1. Do you agree? And then I can regroup. Look at it, guys. I can regroup it. So I can group all the constant terms. So 3 minus 14 plus 1. Those are all the constant terms. Minus 7x minus 2x. Those are the terms involving x. And then there is only one term involving x squared. So if I simplify it, look what happens here, guys. You see, if I simplify it, I get 3 minus 17, right? Plus 1 is just it
should be minus 14, not 17, right?
Minus 14. You are absolutely right. Thank you for correcting me, right? Minus 14. Yes, minus 14 here. And what do we get here? So we get here 4 minus 14. So we get here minus 10, right? Minus 10. Minus 7x minus 2x is minus 9x plus x squared. You see what happened here, guys? And it will happen with any possible situation. We can always regroup the operations. See what we're doing? We're grouping the operations by the number of times multiplication by x is used. So the constant term here means I had to use 0 multiplications by x. Here I had to use 1 multiplication by x. Here I had to use 2 multiplication by x. You see? You see, Christiana and everybody else, is that the reason this definition should work is that I can arrange any operation that involves only addition and multiplication and uses one variable. It can be arranged by the number of times the variable was multiplied by, and it can be arranged into a constant plus a constant times x plus a constant times x squared and onwards. You understand, guys? Not only understand the definition, but understand what is it that we're trying to capture. We're trying to describe, again, all functions that are involving the simplest possible operations, namely addition and multiplication. Good? I hope everybody understands. Please confirm that you understand, guys. Show some life.
Positive.
Positive. Wonderful. Beautiful. You understand. Well, we will see in a moment. No. Yes, thank you, guys. Now, B. Is B a polynomial?
Yes, it is.
Yes, it is.
Yes.
Everybody agrees that B is a polynomial. We don't need to discuss it too long. You can see it's in the right definition form. It's in the definition form. I just wrote it from larger powers to smaller powers, but that's not a problem. Yes, thank you, Giovanni. So this is a polynomial. This is a polynomial. Yes?
Yeah.
Wonderful. Now we are at C. Everybody understands that B is a polynomial. Now tell me if C is a polynomial. And think about it a little bit. So, okay. And we will make the question slightly more complicated than appearances might suggest. Okay. So a lot of people say, no, it is not a polynomial.
It's not because it has division.
Okay, that's very, very interesting, Christiana. So guys, you see what I'm saying. So let's actually do it all together on a new.
Because x to the -2, it's 1 over x squared, which is a rational function.
Yes, yes. Okay, but let me try to confuse you, Christina, as well. Okay, see if I'm successful. You see, guys, in addition to trying to make things clear, one of my goals is to make you very confused. Confusion is very, very important in your life, because when you think everything is clear, you are silly, right? Life is not clear at all. And people that imagine that everything is clear, they are just religious, right? And being just religious is, well, I don't know, not in my book. So here is the function, right? So we have, I forgot what it is already. What was it? It was x to the -2 plus 7x cubed plus 3. So the function is x to the -2 plus, you see, my memory is like that of a goldfish. Plus 7x cubed, that's right, plus 3. Plus 7x cubed plus 3. And this is my function h of x. So a lot of you agreed it's not a polynomial, yes? But notice what you have not. So what Christiana suggested is, look, you see, this is the power x to the -2. What this means the same when we will talk about it either in office hours today, in case you want a reminder of it right away, but we will talk about it when you talk about exponentials. Raising a number to the power of -2 is the same as 1 divided by the number raised to the power squared plus 7x cubed plus 3. So Christiana and maybe some other people that try to justify the same way are saying, look at this expression here. Division is used. Right? Division is used. When we use division, we are using an extra operation. We're not using just multiplication and addition. Yes, Christiana?
It's only addition and multiplication.
Yes, we're supposed to use only addition and multiplication, and here we're using division. That is, but here is my next question, guys. Well, maybe you can write it in a polynomial form. So you see, you agree that you can do something a more difficult way, or you can do it easier. You agree? Right? For example, you can go right now, you can go home. I mean, if you're not home right now, right? Let's say if you are, if you are at Brooklyn College, you can take the bus and you can go home. Or you can, and you don't need to fly to do that, right? Or you can take an airplane, fly to Germany, and then from Germany travel to Poland by train. And then from Poland, take a flight to Israel. And then from Israel, take a plane back to New York and then go home, right? So here you used flying to travel, even though you never had to do it. So my next question is, okay, this is not in polynomial form, as Christiana said, because we're using division, but maybe we can reduce the complexity of operations and arrive at the same exact expression. Same, that you can make the machine more efficient. You can get the same product with less operations. Do you understand what I'm saying? Yes, here I'm using division, and therefore I am using an illegal operation for polynomials. But maybe we can avoid using division. Do you have an argument against that? So maybe you are wrong in saying that this is not a polynomial. And if you don't believe me, I can give you an example where clearly it will be a polynomial. Yes. So for instance, here is a clear case of that. Look at it. So suppose we have t. We have t of x equal to x cubed plus. No, let's have it. Yes, x cubed plus x squared divided. Let's have it like this even. No, not x cubed, but x to the 4. X to the 4 divided by x squared plus 1, right? Here I'm using division. Do you agree? So you might think it's not a polynomial, but look what I can do. I can factor out x squared, and I have here x squared plus 1 divided by x squared plus 1. Now x squared plus 1 never equals 0, so I can cross it out. And simply my answer is x squared. I can reduce the complexity of this operation, and I don't need to use division. Do you agree? Here is definitely an example where you might say, oh, it's not a polynomial, but the answer is yes, it is. You can reduce the number of operations. Now, can I reduce the number of operations in this case? Or maybe you are right and you're saying this is not a polynomial. Can you come up with an argument to say, well, I cannot reduce it? Or maybe you think you can.
You can express it as a fraction.
Well, remember what I'm asking. Can you avoid doing division? Can you? Will it be sufficient to only use multiplication and addition?
We can divide the whole thing by x squared.
Well, I can make it into another expression, but can I avoid using division? Okay, I'll give you 2 minutes to think about it. It's well, this will not be well. Think about it. Look at this expression. It's x to the minus 2 plus 7x cubed plus 3. Here is that same expression. Think whether you can do something with it, and I will look who is here. Okay. Think about it, guys, and can you come up with an argument to say this is not a polynomial, or maybe you think maybe it could be? It is not polynomial, it is undefined. Christiana, what is undefined? I mean, we have a function defined. You might mean something correct, but you haven't finished your sentence, perhaps.
Yeah, because as I told you, Professor, if we divide the whole expression here by x squared.
Divide everything by divide or multiply?
Divide.
If you divide by the whole expression by x squared, you change the expression. Because you see the number is not equal to this expression divided by x squared.
Well, how, like, if we multiply, how we multiply?
Well, I mean, you can multiply by anything divided by itself. That's the same as to multiply by 1, as long as anything by itself is not 0. Be careful there, right? So let's see who is. Think about it, guys, a little bit as I look who is here. Just 1 more minute and we will talk about it. X squared remains, but maybe you cannot figure a way to get rid of the X squared, Humira, right? The question is, can you come up with an argument that, well, you cannot get rid of the division? That's the question I'm asking, okay? So maybe you know some operations, and if you're not able to come up with, you're not able to get rid of division, maybe you are just not knowledgeable enough to do that. But somebody else might be able to do it. That's the question. Or maybe nobody can do it.
You're asking if we could get rid of the division? Like
Exactly, Justin. I'm asking if you can get rid of the division, because if you can get rid of the division, then if you can make it a polynomial. It's like a programming, question,
multiply
right?
the whole thing by X squared, right?
Well, you have to. We will talk about it, right? I'm not saying you can or can't. The question is, can you simplify the operation? Can you only use division and multiplication? Okay. And if you can use only division and multiplication, then it's a polynomial. If it's impossible to reduce it to just division and multiplication, then it's not a polynomial. Clear? Okay, multiply by the denominator. Robert says that, but Robert, be careful. You cannot change the expression. It has to be the same function, right? All right, guys. So let's continue. All right, guys. So any ideas? Let me tell you what you start thinking about, right? So you try, if you are trying to say that you cannot get rid of the division, if you believe that, you need to come up with some observation that will be different about operations involving division as opposed to the operations that are not involving division. So here is the problem with division. There is one number by which you cannot divide. Do you agree? If you divide by 0, it's not going to be defined. The operation is impossible. So look what I can do here. Look at it, guys. If I plug in 0, then that would be 1 over 0 squared plus 7 multiplied by 0 cubed plus 3. And this expression is undefined because I divided by 0. If I could reduce it, do you understand my argument? If I could reduce it to only multiplication and addition, then plugging any number would work. Do you agree? Because multiplication and addition works with every number. So I find that this expression, I like the German word Eigenschaft. I found a property, a unique quality of this particular function that will not be shared by any function that only employs addition and multiplication. Are you seeing what I'm saying, guys? Christiana, everybody? Yes? 0 causes problems. If the function were only needing addition and multiplication, it could digest 0, but it cannot digest 0. Follow? So yeah, that's how I find it, right? I find that something is not like with any function that uses addition and multiplication. So I know that reduction is impossible. Okay, so we now know that this function is not a polynomial. Well, what about this function, guys? What about d? Is d a polynomial? Think about it. Is d a polynomial? So Humira says yes. Again, take your time, think about it, guys. Leverton says yes. Christiana, I think, also said yes. Am I right, Christiana? Karen says yes. Linksing says no. Okay, Robert, interesting what you're saying. Humira, okay, thank you for your for the comment. Both D and E are polynomials. Okay, so somebody said it. I'm not saying I said it, right? I'm right now just quoting your messages. It's so hard to multitask. I need to hire somebody to just do the attendance. It's so annoying. At least for me, it's hard to multitask. Okay. Kind of thing. Rivas. Okay, great. All right, slowly we'll gather you. But shortly. Okay, let's go back to this thing, guys. All right, so what do you think I'm gonna say? Am I gonna say yes or no? You think I'm gonna say yes or no? Okay. You should, by the way, always bet that I say no because I don't like saying yes. It's just not in my nature, right? I sometimes first thing I say is no, and then I might think about it. So here, guys, Humira said that I can factor x out, x squared out, in fact. So I factor out x squared, and here I have x plus 1 divided by x plus 1, yes? And it seems that I can cross, it seems, can I do that?
Yeah.
That's a question mark. Can I cross them out? A number divided by itself is 1. When I cross things out, guys, I'm saying a number divided by itself is 1. But except 0. 0 divided by 0 isn't 1. 0 divided by 0 is undefined. You see? So this equals, look at it, this equals to x squared if x isn't equal to minus 1. That's the if. Okay? Because if x is equal to minus 1, x plus 1 is 0 divided by 0. Are you seeing that? So I cannot divide, I cannot simplify it in the one instance where x equals to minus 1. So the function is very similar to x squared, but it's not equal to x squared at the moment where x equals to minus 1. So strictly speaking, it is not a polynomial, right? I will make it like this, okay? So strictly speaking, so it's not a polynomial, yes, Humira. It's very close to it, and later on when you go to complex analysis and other things, it's basically a polynomial in everything but name. In other words, it's it's like a deposed king. It's very much similar to a polynomial, so you are not entirely wrong in calling it, right? Because there is only one number for which this fails to work. So what we will say is that it's not a polynomial, but I will write a v with a cross because it's so close, right? It's so close. Strictly speaking, the answer is no, but there is only one instance where we have problems. That's when we can reduce it to x squared. It's just x squared, except for the moment where x is equal to minus 1. You understand? Because x plus 1 divided by x plus 1 can be simplified to 1 unless the expression is 0. X plus 1 can equal 0. What do you mean guess these instances? I mean, you can write a very difficult problem where it's very difficult to know whether it's a polynomial or not. But in this case, just basic factorization. So, okay, guys, now go through E. Is E a polynomial? Is E a polynomial? And Robert says yes. And Francis says yes. Yes, we already did this problem. It's a polynomial. Let's look again what happens. Why am I able to simplify here? Well, look at it. I can factor out an x squared, right? So this is x squared, and this time, what do I multiply x squared by? I multiply it by x squared plus 1 divided by x squared plus 1. Now, x squared plus 1 never equals 0. Do you agree? Because well, that's actually another funny thing. In complex analysis, you can make it equal 0. You can plug in I, root of minus 1, right? But here in the real numbers, there is no solution because take any number, when you square it, it's positive, or 0, plus 1, it's positive. You see? So here I can remove this part without any problem. because it's a number divided by itself. The number is not 0. We'll get 1. Do you understand? X squared plus 1 never equals 0. So x squared plus 1 over x squared plus 1 always equals to 1. And so this is the polynomial x squared. You see what I did? I made the operation more efficient. I don't need to use division. I don't need to even use too many additions. Right? I made a much more efficient operation that does exactly the same thing. Clear?
Wait, I have a question. You said x squared plus 1 never equals 0, but x squared plus 1 always equals 1.
No. I said x squared plus 1 divided by x squared plus 1 always equals 1.
Okay, thank you.
You see the difference, right? X squared plus 1 can equal a lot of numbers, but if you take x squared plus 1 divided by itself, you will always get 1. Why? Because then x squared plus 1 never 0. So you cannot simplify 0 over 0, but you can simplify 5 over 5 or a million over a million. It's always 1. Okay, good. Amazing. Okay. Now, what about this, guys? When is the exam? Oh my God, guys, relax about the exam. Are you ready for it? That's the question you should be asking. Are you ready for the exam? Not when is it? The exam might be at night. I just wake up and I feel exam. I'll climb through your window. I wake you up and with cold water and I said, exam! And you should be ready for it. Right away, calculus is spewing out of your intestines. Good? Because it's supposed to be in the gut, not even here, in the gut. That's when you know it. Good. Let's get it. So, right? You should watch the movie The Life of Others. You can find it on Amazon Prime. It's called Das Leben der Anderen. It's a very good movie. So you understand how you prepare for exams in East Germany. Will it teach calculus? I for a moment thought that I am an it. Well, that's nice. Yes, it's not calculus just yet, right? It is, some ideas that we need to have a better understanding of math in general. Guys, now let's do F. Is this a polynomial? Why, Robert? Why are you completely stumped? You're not completely stumped. We just said something very simple, guys. Isn't it? I mean, it's not terribly, right? I mean, how to verify whether something is a polynomial or not can be scary, but we understand what a polynomial is. It's just like an efficient machine, an efficient program that only uses addition and multiplication. That's all. So is this a polynomial? So no, because it's not an integer. You mean there is a non-integer power involved, okay? So somebody says 1/2 is not, so Jahin, you're saying 1/2 is not an integer, but be careful, guys. Again, the question is, maybe you're right, it's not in polynomial form. Where there's a 1/2, it's not in polynomial form, but maybe somebody else can write and make it into polynomial form. Do you understand my question? Yes, exactly. So what is the 1/2 power, guys? Okay, so by the way, the class is over at 3:30. I forget when is it over. 3:30, yes? It's just so little time. It's terrible, right? It should be over at 5. Okay, so some people are saying the following, right? So they are paying attention to this. Humira, because the square root of which number is imaginary? So maybe Humira is saying something brilliant. Exactly, Humira, brilliant, brilliant. Look at it. So you pay attention to this expression. What is x to the 1/2? That means root You're taking square roots. Square roots are rather complicated operations. They're even more complicated than division. Yes, but maybe, and that's, by the way, something we will try to figure out. How, if you were stuck on an island and you lost your calculator or your devices, will you calculate square roots or roots in general? We will address that question as well, right? So you can think, how are machines calculating square roots, and therefore how you are calculating square roots. But it's a complicated operation. And how do we know this operation cannot be replaced by mere multiplication and addition? Well, one thing is this, guys. So you know that addition and multiplication works for all numbers. But let's say square root of minus 25, square root of minus 25 is undefined. If you take a positive number multiplied by itself, you get a positive number. If you take a negative number multiplied by itself, you get a positive number. You understand what the square root of minus 25 means? It tells me, find me a number such that when this number is multiplied by itself, you will get minus 25. But if I take a number from the category of positive numbers and multiply by itself, I get positive number. If I take a negative number multiplied by itself, I get a positive number. And 0 multiplied by itself is 0. By the way, guys, you memorize that a negative number times a negative number is positive. Do you know why? That's all questions that it should not be, it should be obvious to you why negative times negative is positive. Those things we can discuss again if you want to have a feel for it. Okay, you're supposed to have, it's not supposed to be something that you memorized from what a teacher told you. You're supposed to know it. If you know it, then you understand also why complex numbers emerge. So there are so many interesting things relating to it. Okay, so again, if you are interested, I can give you a discussion, a short discussion about what real numbers are, at least to give you an idea of how to work with them, what multiplication means geometrically, how people thought of numbers before you wrote those symbols that you have right now. I can give you an overview. All you have to do is ask. And the question is not whether or not it's on the test. The question is whether or not I know it. Good? So the answer is no, it's not a polynomial. Clear? It's not a polynomial because this function does not digest negative numbers. But a polynomial can digest all numbers just because multiplication and addition works for all numbers. Do you understand? Yes? Shake your head that you understand, guys. And you're not shaking it just because you're iguanas that are challenging me, right? You're just shaking it because, yes, you understand. Good. Not all of you are shaking your head. Exactly. Good. So we figured it out, guys, and you all know that my notes are on my website. You don't let them be lonely. I wrote it for you. Read my notes before, after class, during, I don't know. Okay, now let's talk about some properties of polynomials and limits. Okay, polynomials and limits. You remember limit laws, right? Limit of a sum is the sum of limits. Yes? Yes, guys, you're supposed to know that, right? So that's how, you're supposed to open books, you're supposed to look into the notes, right? Otherwise, right, so limit as x goes to a of p of x, that's my theorem, is that calculating limits gives you exactly the same result as just plugging in the value. Polynomials behave very nicely with limits. Could you remind me, now some people don't remember the word limit. By the way, if you don't remember the word limit, you should listen to Scarface, Welcome to the Limit song, right? That will help you. What is a limit? Would anybody tell me what is limit? What do you do? So when I, for example, calculate a limit as x goes to 3 of x squared versus 3 squared. what's the difference? You see here, I am using the square operation in both situations, but in one on the left, I'm using limit. What am I doing?
Well, a limit tells us the value that a function approaches when we input that value. Like
as easy as possible, what am I so the function, what is the function that we're using in both cases? In both cases, we're using the function f of x equal to x squared. And what does this mean? It means that we're saying this: give me a number and the number will be multiplied by itself. That's what it means. F of x equal to x squared means that the operation is you take the number and you multiply that number by itself. Is it a polynomial operation?
yes.
Obviously, guys, don't be afraid, right? Obviously, it's polynomial because you're just using multiplication. If we're using only the operations of addition and multiplication and no other operations beyond that, it's a polynomial. Okay? Good. Now, what am I plugging in when I take limit as x goes to 3? I'm plugging something in in other words, I'm taking
something
this
very
operation.
close to 3.
Sorry?
Something very close to 3.
Brilliant. We're plugging something very close to 3. Good. So limits are very simple, guys. You're just plugging in values that are close to 3. Do you remember my water gun analogy? Is that you're plugging infinitely many values. So if this is my function, so look at it. Here is a picture for the expression f of 3. This is f of 3. So here is 3. And here is 3. So f of 3, I have this turret, this water gun. I just feed one particle and I get it here. That's f of 3. Yes? What is limit as f goes to 3? It's that same turret stationed at 3. And what I do is I open up a faucet. I open up this pipe. And I plug everything except for 3. 3 plus and 3 minus. And then I have a gushing torrent of water. Okay? That's what happens with the limit. Do you understand the difference? They are very different operations. Here I plug into the function all values close to 3. Here I plug the value exactly equal to 3. So you're not confused. It's not 1/3. It's 3. Good. And what happens when I take the limit? When I take the limit, I compress the input valve. In other words, when I say I plug values closer and closer to 3, that means that those valves compress. Let's say now they're smaller. Now the current is hopefully narrower. Yes? And the current, if it focuses around one point, the limit exists. It's very simple. You agree? If you think about it, then what the limit is doing is very simple. Now, what do you think the current will be focused at? What do you think is going to be the focus point of the current here for limit as x goes to 3 of x squared? So I am closing the valve of the input around 3. The water squirting out of the gun is focused. Around what point will it be focused? Nine. Exactly. It will focus around 9. And what do you think is this point here? What do you think is this point here? F of 3 is also 9. So even though the operations are entirely different, the numerical value that we give as our end result is the same in both situations. Yes? That's what will happen with every polynomial. If you carry out every polynomial, no matter how complex, and you take the limit operation at any number, the beam of water will focus around the same point that the lonely particle is launched. Let's try to see that. Okay, so we're given any polynomial, the limit as x goes to a of p of x will be p of a. This says that applying the limits on any polynomial yields the same result as just plugging in the number. Okay, so let's try to understand why that should work by the limit laws. You see, guys, right? So if you feel lost, why are you lost? Because the word polynomial, the word limit, are empty words. It's like you are not processing, you don't have the player to open this video. It's a video, you understand? So you translate those words and you're supposed to process and you're supposed to see. It's the same that what happens if you read a book in a language that you don't understand. You just see gibberish, symbols. But what you should be seeing is meaning. Sorry?
One quick question. This rule applies only to polynomials?
No, I didn't say that. I just said that
Okay.
if you have a polynomial, you can be rather safe at figuring out what the limit is.
Okay.
Right? Don't ever assume more than the statement. The statement says, if I am having a polynomial, take a limit, you will get exactly the same result as if you just plug in the value. Right? Take limit as x goes to 3. You don't need to bother with this more complicated operation. Just plug in 3. But make sure, guys, that you understand limits are very different operations. Okay, so people, when they take calculus, they just notice you plug in 3, you get the right answer. You did the wrong operation. It just tells you do the operation of plugging in the number 3. You will get 9 in the previous example. Take the limit, you will also get 9. Okay, both operations give you the same end result. Okay, but limit is not the same as plugging values in. Very different. So here is the proof. So a polynomial can be written as b0 plus b1x plus b2x squared plus bnx to the n. Agreed? So we use addition and multiplication. Now look at it. I can first use the limit law for addition and break it into limit of each chunk separately. Because the limit of the sum is the sum of the limits. That's kind of intuitive, guys. We can prove that if you have the interest and the energy, I can prove it to be true. The limit laws are theorems. You have to prove them. But intuitively, you think if you add two quantities, let's say if you add a quantity that's similar to 2 and a quantity similar to 3, the sum of the quantities will be similar to 5. You agree? So limit of a sum is the sum of the limits. You agree? Limits is talking about similarity. Understand? You look confused, some of you. So we have limit of the sum is the sum of the limits. Now, each part we already know how to calculate. Each part we use recursively the limit of the product. Let me remind you again, guys. You look too confused for me to feel happy. So let me remind you, right? So tell me, please, what is limit as x goes to a of the number b? What's the answer? In other words, you understand what I'm asking? What's limit as x goes to 3 of 7? Careful, you're saying a here. Look at it, guys. So this means what's limit as x goes to the number 3 of the number 17? That's what I'm asking. B. Here it is 17 below. You understand? It's just symbolically talking about all possible limits where x goes to one number and we're evaluating some number, right? Constant. So that would be 17 here. Do you agree? Because when x, in other words, I'm having, what is this function? This function is always spitting out, no matter what you plug into the function. This is the function. The function here is f of x equal to 17. So if you take limit as x goes to a of f of x, or as x, I said 3 here, right? As x goes to 3 of f of x, you're plugging numbers close to 3. Not equal to 3, but close to 3. But all numbers that you plug into the function give you 17. So it doesn't matter if you plug a number close to 3 or 3 itself, you're getting 17 all the time. Exactly 17, actually. You understand? What this function, a constant function, is saying is that the function is transforming every single number into 17. Give it 0, it will give you 17. Give it 12, it will give you 17. Okay, so here you're giving the function numbers that are similar to 3. What are you getting? You're getting 17. Good. This is easy, right? This is trivial. So in general, limit as x goes to a of b, that means the function is always giving you b. The answer is going to be b. Correct? Guys, by the way, another thing, you're saying yes, but you are like accumulators, right? I mean, I spoke about it on Thursday. You forgot a lot about it already, right? That means you haven't opened the notes. That means you haven't been doing anything. You have to read it. You have to study. Otherwise, it's not going to work well. Can I repeat what, Francis? Exactly. So the limit as x goes to 3 of a constant function will be the constant. Right? In this case, if the function is always equal to 17, why it's b for the top part? Well, because x is going to a and the function is always producing a b. That's what it means, right? The function is always producing, the b just means some number. X is going to one number, the production is some number. Yes? Humira depends on what is bx. So this is just b. Now, depends what you mean by bx is now a function, right? So what about this, guys? What is the limit as x approaches a of x equal to? No, Robert, not x. It is a. Do you understand what this means? Why is this a? Would anybody wish to explain it to me? Why is the answer a? B, exactly, it's tautological. If a number is getting similar to a, what is the number getting similar to? That's what this is saying, right? You're getting numbers that are getting similar to a. What are those numbers getting similar to? They're getting similar to a. Good? Is that clear? So if the number is similar to, let's say, so if I have here a limit as x goes to 2 of x, what am I getting here? I'm getting, let's say, 2.01, 2.0, so that's what x equals to 2.001. You can see that x is getting similar to 2. So obviously you will get 2 here. You understand? So some limits are very simple. So limits of a constant is very simple, and limit of x is very simple. Yes? Now, what would be the next level? What is the limit as x goes to a of x squared? What is that equal to? We can use the product operation. This is the same as limit as x goes to a, x multiplied by x. Francis, x squared is meaningless. It just means we're plugging numbers approaching to the particular number a. So the answer will be, look at it. Here we are multiplying numbers that are similar to a by each other, as opposed to multiplying a by a. You understand? So the answer is a squared. What really happens, guys? What really happens? So here, let's say limit as x goes to 2 of x squared. What is that going to be? So you can imagine that what you're doing is, let's say, 2.01 multiplied by itself, and then 2.001 multiplied by itself, and then 2.00001 multiplied by itself. Right? The results are going to be, if you take a number similar to 2 and multiply it by a number similar to 2, you'll get a number similar to 4. That's the idea. You understand? It should be an animation. You're not plugging in the value, but you're getting that. And in general, you can see that limit as x goes to a of x to any power n will be a to the n. You agree? Here we're just multiplying. Again, you see, guys, if you want to truly understand it, you need to prove it. But it seems intuitive that if you multiply a number that is very good imitation of a many times by itself. If the imitation is very, very good, then the product will be very similar to a to the n. That's what you're trying to say. Okay, and that's what happens here. You see this? So we break it into addition, so we can add. So if there's addition, the limit of the sum is the sum of the limits that we described on Thursday. So this limit plus this limit plus this limit, in each of those limits are easy enough to figure out what they must be. Okay, so review limit laws and think, do you at least intuitively understand why this is true? I hope you do. Okay, we have this. Now, I mentioned that polynomials are simplest types of functions. You encounter them all the time. So we are using, in our number system, we're using a base 10 system. What's the base 10 about? Look at it. So what we have is, for example, what is 1,806? This means we have 6 individual units, 0 units of 10, 8 units of 10 squared, because we have 800, and 1 unit of 10 cubed, which is the 1,000. Yes? So if you look at this x, look at it. What is this x? This x is 10. 10 is the x. So 1,806 is very much like 6 plus 8x squared plus x cubed. So polynomials are very similar to integers. So integers in whole numbers should remind you of polynomials. Do you see that? So the number 1,806 is very similar to the polynomial 6 plus 8x squared plus x cubed. Good? We're going to return to that, okay, guys? So base 10 system means that we are arranging in powers of 10. That's how we are grouping numbers. We're arranging in bundles of 10. So unitary bundles until you get to 10 objects, then you have to arrange them into one bundle. So if you have 10 separate matches, you have to tie them together into a bundle of one bundle of 10. Good? The next bundling is when you get to 100. The next is when you get to 1,000. Good? So here is the next question, guys. What's the next level of difficulty for functions? So we have polynomials. They are the simplest operations because they only use multiplication and addition. What's the next level of difficulty? Next functions.
Rational function.
Exactly. So now we are allowed to introduce division. Yes? So here is a rational function is one that uses division. And so this is a rational function. If you agreed, Rx 1 over x plus 2x plus 1 over x squared. Now I'm trying to show you the following, guys. If you have to use division, you can use it exactly once. So anytime you have to use division, you can reduce to the situation where you use that new operation exactly once. And I'm trying to show you first with a simple example. Look at it. Here I use division exactly twice. You agree? Now I'm going to reduce it to the situation where I use it exactly once. So I just write a common denominator. If it's 1 over x, I multiply top and bottom by x. Right? It's x over x squared. Here, to make it have the same denominator as x squared, I multiply top and bottom by x squared. So it's 2x cubed divided by x squared plus 1 over x squared. So now they all have the same denominator, which I can then factor, and I can write it as 1 plus x plus 2x cubed divided by x squared. Do you see what I did? I had 2 instances of division, and I reduced it to only 1 instance of division. Yes? You can do it with every operation, with any rational operation. I hope you see why. Because if you use several divisions, it is something divided by denominator. Something divided by denominator. You can find a least common denominator and add them together. And then you have only 1 instance of division. Do you see that? just like when you had with regular fractions, right? It's exactly the same as with integers, right? When you had something like 1/2 plus 5/7 plus 2/3, right? What do? You convert the denominator. So the 2 you convert, you have 2 times 3 times 7, and so here you have 1 times 3 times 7 plus 5/7. So you have 5. We have a 7 here. We need a 2 and we need a 3. So it's 5 times 2 times 3. Yeah, and onwards. So you see, you just have, you understand what I'm saying, right? You can it's the same exact reason that you had for adding fractions. You'll remember how to add fractions, right? I wrote it so kind of negligently, but you all remember how to add fractions. Do you? Yes, well, if you have any problem with it, we can discuss it. I mean, at least I can tell you what makes me understand it, right? I can only repeat things well and be sure about them when I understand why it works. When you don't understand why it works, you are just like in the Charlie Chaplin movie, right? You're working in a factory and just doing this, right? So it's neither intellectual and it's meaningless. Right? So I want you not to do this. I want you to really understand what everything means. And the more you understand what everything means, truly, the harder it is to confuse you. You know your way around. You know your neighborhood. Right? So I hope you understand that if I have rational functions, if I have to use division, I can reduce it to the situation where I use division once. And that gives me this definition. A rational map is a function Rx where I take one polynomial divided by another polynomial. Okay, so it's a ratio of 2 polynomials, just like a rational fraction. Well, a rational number is a ratio of 2 integers. Same thing. You're just like recreating the numbers, but with functions now. Good. So, for instance, this is a rational function. Do you agree? It's a polynomial divided by a polynomial. You use addition and multiplication and one division. Any polynomial is also a rational function. Why? So polynomials are rational functions. Very simply, why? Because it's over 1. Amazing, Humir, right? You can divide by 1, and you can introduce division if you want to, right? You can always introduce more operations. You agree? So if you are using more operations, that's a bigger category, because you are always free, if you have the ability to use new operations, to just introduce them even if they are not required. Yes, Angela?
I didn't ask anything.
No, I'm saying yes, you agree with me? I'm just look at your face here, and I thought, well, I want to feel that you have those glasses. You look like you should agree with me. Yes. So, okay, so here is the next theorem. Okay, next theorem is that limit as x goes to a of Rx is the same as evaluating the numerator at a divided by the denominator at a, unless the denominator is 0. Okay, so limits for rational functions are easy to calculate unless denominator produces 0. You see what I'm saying, right? So limits, the idea is very different, but calculating it is easy for polynomials because you actually don't need to use the limit operation. You can just plug in the number. You can just decide to pick another operation and you'll get the same result. You can do the same with rational functions, but only if denominator is not 0. Yes? And what's the proof? It's very simple. We already know that limit as x goes to a of px is pa, limit of qx is qa, and we have a limit law for quotient. The limit of the quotient is the quotient of the limits, unless the denominator produces 0. That's what the limit law is saying, guys, right? I hope you remember it. So here is an example. Do me a favor and calculate limit as x goes to 1 of x squared minus 1, x minus 1, okay? I will let you go in a few moments. If you have to leave, you can leave. since class time is over. But guys, I recommend you stay after class, right? I recommend you ask me questions if you have them. And if you are interested, we can talk about constructible numbers, about how to view numbers geometrically. What is the real number line? Why some properties of real numbers hold. Okay, Christina, thank you. What's limits? What are you saying limits? Jet Lord, Joanna said, what the topic is called? Yes, topic is called, well, it's called the limit laws specifically. So it's limits and limit laws. But guys, you have my notes, guys, you have my notes. You look through the notes. All right, so you think about it and let me see who is here. Al-Gabai Zayed here.
I'm here.
Okay. Ansari Humira here.
Here.
Of course, I think you participated a lot. Okay. Chowdhury, Faiza Shaukat here.
Here.
Okay. Artikov Sharuz. Diane Barbara. Fang Liu. Yes, my website is etkin.com. All right. Okay. All right, so are you ready, guys? All right, so let's quickly solve this one problem. So very simply, what can you do? Look at it. You cannot plug 1 because then you divide by 0. So you factor it out. You see, you write the numerator as x minus 1, x plus 1. And because limit is going to 1, well, I haven't called all the names, guys, right? If you want to, if you're very worried about being on the attendance, I have taken only partial attendance, right? I mean, it's really not whether you miss one or not class. I just want to see that you are on your toes. So x minus 1, x plus 1. If you want me to mark you as present, we can do it after I finish. But don't worry. I mean, it's fine. I mean, I'm just checking several days, and I just see if you're generally attending. It doesn't matter if you attend every single second. Besides, you can be afraid that maybe the time I take attendance, you are not there. So we have x minus 1. I can cross it out because it's not equal to 0, because x approaches 1. Right? So this is cross out, and then we have x is going to 1 of x plus 1 is 2. Brilliant. All right, guys. So today's lecture, the official time is finished. I will stop the video. If you want to discuss further material, you stay with me. If you want a what, when, where question at some moment, you stay with me.